Out of all of the 3D printers that I have, the K2 Pro is the latest, theoretically greatest, and most premium one, but how good is it really, and is it worthy of that Pro title? As you can see here, there's a bit more to my specific machine than meets the eye, and there's two major reasons for that. So now it's time to head back to August and see how this journey really begins. Being my first consumer Core XY 3D printer, it was a tad surreal with the only assembly being the screen and removing a few shipment protection features. Everything arrived safely in one piece, which was a good start. It was also good timing with getting my hands on this machine as I was nearing the later stages of my Voron Limits video and really wanted to print out the larger motor mount out of ABS glass fiber, which wouldn't have been possible, at least easily, on the Creality High. I need a stronger table, this thing's shaking my whole table. You seeing that? I need to upgrade my whole table. For my first ever print on this machine with no tuning, no nothing, I was very pleased, and the part held up very nicely on the V0 in the end. We were off to a great start. I also printed about half the parts needed for this camera jib straight afterwards, but we'll get to that later. It's time for a machine rundown as a closer look at what Creality has cooked up for the MSRP of $849 USD for the machine and $10.99 for the combo is high on my list. I have the combo here, but I don't do any multicolor or multi-material printing with the CFS unit, so this topic has been excluded. I do include it in my Creality High video, but not crazily in depth. The most notable feature, I'd say, is the frame. It's definitely the strongest one I have in the studio out of all the machines, and while I won't be testing it like Nathan did, it's at least something that Creality seems to have done well on. Disassembly isn't something I was able to test, however, there's more on that later. On the front is the articulating touchscreen, and on the right is a USB port and RFID reader for the filament, and on the left is nothing. On the back sits the filament buffer, waste chute and power socket alongside the Ethernet port and CFS connector. There is a single stepper motor that drives the Z-axis, which upon closer inspection is actually a Moons branded motor. Nice. The frame is grounded, and next to that wire is the chamber heater. It has a thermal fuse, and I believe it runs off 110 volts AC. The main power supply is a very small 24 volt DC 150 watt model, since the bed and chamber both run off mains voltage. There is a blower fan for cooling this additional board, which handles the mains voltages. Above that is the filter exhaust fan, and above that is one of the drive motors alongside its tensioner. This machine uses 9mm belts, but I cannot confirm if the motors are using double shear. It doesn't matter, as past a certain tensioning point, presumably due to the smooth idlers on the gantry, artifacting becomes very prominent. At the top is an exhaust fan for the chamber, which does enable printing PLA with the lid on. The chamber sits at around 35 degrees in that scenario. Taking the lid off, we can see the reverse Bowden tube mounting to the drag chain, and the wire path is quite something, which is the likely culprit for some issues I had later on. Looking into the machine is the textured PEI print surface, chamber thermistor, silicone nozzle brush, and waste chute, alongside a 12032 auxiliary cooling fan as well. Only one. Moving on to the tool head, there is a fan for cooling the extruder motor, a fan on the back which handles tool head part cooling, and after taking off my resin printed clear cover, we can take a look at the hot end and extruder. After poorly taking off the sticker and pulling out the extruder, we're greeted with a NEMA 14 looking motor. The hot end is a 100 watt ceramic style, much like the Creality High, and as mentioned earlier, I currently have an Obsidian 0.6mm nozzle installed. I forgot to mention that earlier, but Creality does seem to be using genuine Gates belts on this machine. Very good. Under the tool head are some LEDs and a camera for the pressure advance and flow tuning alongside print failure detection, which I will admit only triggered once using its default settings, despite the many failures that I did encounter. I can only assume that it'll progress over time. It did work, once at least, and saved a little bit of trouble there. Moving on to the underside of the machine, there is that single NEMA 17 driving the 2 lead screws, which I kept in sync with a timing belt. Dual Z with 2 steppers would have been nice to be able to do Z tilt function, but this seems to be fine. There is a tensioner for the timing belt as well, which I did use upon noticing how loose the belt seemed to feel. Finally, in the chamber, there is also a little camera for time lapses and print viewing. I found that regular time lapses worked well, and I've got one for almost every print I've done, but there is also a smooth setting, where the slicer creates an additional extrusion tower on the back for the tool head to move over to supposedly create those super smooth time lapses we can often see in other videos. Wow, my speaking is pretty bad at the moment. But in my case, it was nearly identical to the classic time lapse option. I only tested this with one print though. Let's chuck some filament into the dryer in preparation for testing. The Creality SpacePi X4 is my third and hopefully final dryer, as it's pretty much the only 3D printing related machine that hasn't given me any troubles. That being said, it's not the cheapest item. Creality sent it here a few months ago. It was around now I had my first of the 2 firmware updates on this machine. It's a very easy process to complete, literally one tap. In regards to taps, we can enable calibration for the auto leveling, cutter calibration, and input shaping, and the machine handles this nicely. This process does take around 15 to 20 minutes, although it could be faster if the strain gauge homing sequence was a little bit faster. I think the machine could handle it considering how fast tap is on Voron. Let's take a look at the menus, although the front menu that I'm showing now does get updated right at the end of the video. Here's how it looks there. I honestly prefer the previous one. In page 1, we can control fans, heaters, and disable the motors. Page 2 is for filament loading and unloading and naming. Page 3 are the camera features, and page 4 houses the self-check functions. It's all nice and simple and clean. The file folder houses the history tab showcasing a print preview, start date, print time, and the success status. The local tab shows prints stored on the 32GB ROM, which I've barely made a dent in despite keeping all my prints there, and while I skipped over it, the USB tab shows files on the side-mounted USB stick. The settings icon has Creality Cloud stuff. The system tab regards firmware, the network tab is of course network related, and the general tab holds the bulk of all the settings, including route details, the about page which has the print hours and machine ID, and the expert mode with 2 out of the 3 features being only available during printing. As you can see, I already have 50 hours on this machine, or about 1/3 of what I actually put out on total. Put on total. The final utility page is one I hardly used, although the error tab did have quite a stockpile during the end of this video. As you can see, it's already become acquainted with quite a few non-urgent errors. Moving on from the printer, surprisingly, it's time to take a look at another new Creality product, sent to be also included in this video. It's an air purifier and a separate purchase from the K2 Pro, and it gets pretty close to the cost of the machine itself. I believe it's going for $600 at the time of writing, which is no small amount. I have no experience with air purifiers, so for obvious reasons, I'm quite curious about it. For about 80 to 100 hours of my print time, I've had the air purifier running, but not with the exhaust port connected to the machine, as I was unsure about how to connect it, and I couldn't find any files for that mount. I was planning on cooking one up later on, but I wasn't able to. A lot of testing ended up getting cut short for several reasons. You'll see the first shortly. It's such a little thing, but I don't know, I find that pretty cool. I've got my priorities all around the place. Anyway, the important details. Let's check this out. Nah, it gets crazier. There's a white power cable in there too. We have some kind of funnel and the actual tube itself, which is very rugged, and it does move. I can't do that with one hand though. So this thing articulates. It's very interesting. Oh no. Oh, that's unfortunate. This is a US plug. We don't have those here in New Zealand. Remove that. Wow, that is, okay, that's a big filter. I've never seen an air purifier before, so I don't know, but this seems huge. Oh, it's heavy. Let's look inside. Wow, that's pretty interesting. Yep, not too much going on in there. And can now remove this. So this looks very interesting. Yep, some kind of propeller looking thing. I guess I just push this. Oh, very interesting. Let's do some regular old printing now, and no, we're not going to be printing printer parts, which is something I had to tell myself twice to fully comprehend. It's not often I print leisure parts, except for this monster of a video, or the Elegoo one, so I wanted to do lots of that to use up my remaining filament and put some hours on this machine. First up is the Hestia knife, printed in Anycubic black PLA and a 0.12mm layer height for a nice finish. I was very curious about how the runes on the blade would fare, as they were quite detailed. I will admit the surface of the handle was looking great with such a fine layer height, but it was upon taking a closer look that something became apparent. I tried this print again with a higher belt tension, which seemed to emphasize this effect even more. It was quite interesting, giving it an almost mini fuzzy skin texture to the blades. Of course, that wasn't what I was after. I printed 2 more blades in grey and orange PLA, and the patterns still remained in varying levels. I want to believe it's due to those smooth idlers interfacing with a tooth belt. I wanted to replace them with tooth pulleys to test, but apparently that could be extremely hard to do, or straight up not possible. This machine is unfortunately not an Ender 3 in terms of repairability. These more modern machines just don't compare in that area, unfortunately. This would be fine if they were constantly reliable and working, but there's going to be issues eventually. While this is only printing PLA, the air purifier still reads a PM 2.5 value of 1, which is of course good, but I never saw it go higher than that. Maybe there was good airflow. This was despite printing ABS overnight with the machines side by side. Moving on to a big print batch of ABS glass fiber to test bed leveling, a longer print, and well, a bit of everything. I'm a huge fan of Sidiment ABS glass fiber, which I've all purchased myself as it's a very forgiving material to print with, and at least, as I've found, gives a nice surface finish. One of the parts did fail, but the object exclude function that can be done on the touchscreen of the printer made continuing the print super easy. I used that feature quite a few times given I had trouble keeping my bed clean, but we got there in the end. Here are some of the close-ups of the prints. My supports and top surfaces could do with some tweaking, as I never touched those settings, and the text might need some tuning as well. Or maybe that's just a 0.6mm nozzle struggling with that. I'm pretty sure that's what I used for the majority of my prints, but I do switch to a 0.4mm for the remaining 60% or so of prints later on. I was very conservative on part cooling, so it looks like the overhangs could do with some more of that. I then reprinted the remaining parts and the classic all-in-one test with a Benchy alongside it. All prints came out brilliantly with minor retraction and bridging optimizations to be considered going forward. I wanted to try some larger prints now, which is where things get interesting. I chose this Hollow Knight needle prop and some orange PLA, but for some reason the print must have been knocked over or come loose near the end, as it came crashing down during the last minute. It was definitely the biggest print failure I had in this video. I reprinted some of the parts, but noticed that the print quality seemed to get worse the higher I printed. This was unchanged with different Z-hop settings in the future prints. Thankfully, the remaining parts came out great. I've just finished assembling the needle with a bunch of super glue. It's not perfect, but wow, it looks pretty cool. My Ender 5 has been allocated some more attention in this video, as I'd otherwise struggle to justify it, so let's give it some of that. I was originally going to make this video a showdown, with all of my printers facing off against the K2 Pro, but considering they're all in need of quite a lot of care, this would have been several videos of work in one, which wouldn't have been possible this time round. I then thought about making this a dual, but even that was just conflicting, so ultimately I'm just using the K2 Pro to print parts for the other machine, and will once again put off getting it fully tuned and working. I mainly needed an excuse to put the new mainboard in and set it up, which Bigtree Tech kindly provided for this machine and video. I've never used an Octopus mainboard, being a Kraken lover, but I like it already. I'm no short of biased though, as I use Bigtree Tech stuff a lot and love them to bits. They've gone above and beyond for the upcoming custom printer series, which I owe them for. I'm just going with basic 2209 drivers for this machine and 24 volts, as all-wheel drive gives us plenty of travel speed, with the bottleneck still being these front towers. I'll either need to CNC machine these tensioning blocks, the towers themselves, or design them myself to make them a bit easier to use. That comes at the cost of a lower quality design, however, and it won't be until my Fusion 360 learning arc when I hope to make some actual progress on that front. After 2 days of config work, since I like to make things way more complicated than necessary, we're up and printing. After a year or so of hibernation, it's good to get the Merc 1.1 back up and running. Love it. Now, while technically speaking this is a passable Benchy, it's not a good one, and there's some reasoning behind that. Z-axis is still a bit wobbly, even with the support struts, but that's just how it is. On the topic of printing, I asked PCBWay to make something for the K2 Pro, and they more than delivered on that. I got this tool head cover printed in UTR 8100 transparent resin, and it turned out beautifully. Their customer service flagged the model as having a bit of a risk in transit, so they suggested having a little support piece printed with it to help it with the journey, which was a great call. Everything arrived fast and safe as always. This is my 7th time using PCBWay's services, and I'm constantly pleased with what they're capable of. If you're keen on trying their services like I've done in my past projects, whether that's with machined carbon fiber, clear SLA resin printing, laser cutting and anodizing with laser engraving on top, PCBWay can make it all happen. With their ongoing Christmas sales, you can get coupons to save big on top of sweet discounts on CNC machining of up to 50%, and coincidentally, discounts on transparent resin, which is a huge win. Thank you PCBWay for supporting this video. So this is really annoying. I've got the chamber all heated up. It took like 45 minutes. I'll time that, and there's me in the reflection. So the problem is I can't get the nozzle in all the way now. It just won't. It starts spinning the heater blocks. This is very weird. It's probably, I don't know why. So there is an abnormal amount of resistance if I try and either way. So I've tried different temperatures. This is really odd. This is really, really odd. And I'm a bit stuck. So the issue is here, look, if I do this now, the whole thing spins, which is a little bit of an issue. I did get some feedback from Creality, but it was unfortunately advice for techniques I had already tried the previous day. Due to some internal changes at Creality regarding the rep I was in contact with, that conversation came to a close. Since I was, of course, both too far in and not enough to call it quits, and didn't want to spend the money on a replacement hot end just yet, I remembered back to my previous video. With the Carvera Air in the studio, I could easily machine custom aluminium pieces, which for a hot end mount that required rigidity was a huge deal. The first step was prototyping a custom mount, which thankfully was super easy to get a revision up. I was honestly a bit hesitant about doing this at first, but with some words of encouragement from Angus from MindKits, we pushed on. My revision was apparently a bit, well, not controversial, but definitely unrefined. It would have meant that the Rapido Ace would be using 2 heatsinks, which would have been quite funny. It also would have been very hard to machine, so I'm pleased that the final version I came up with was super simple and very easy to make out of the aluminium I had on hand. After some testing with a PLA prototype first, of course, and seeing that the design was usable, it was then time to cut some chips. I've just installed the sock, which looks amazing. I just need to do some more cable management. But hey, the Benchy finished, and it doesn't look half bad. It's not great, but it is good. And I'm very pleased about that, considering all the calibration prints kind of failed, and I haven't done input shaper. The difference between the completed part and the prototype were night and day, and that was without chamfering the edges, deburring, polishing, or any of that stuff. The new test Benchy came out good, although I wanted to switch to a new nozzle. I forgot to mention it, but since the new hot end adapter is much shorter than the old one, I had to add a melt zone extender, which will give us a higher flow rate, but I'm a tad unsure at how it will affect print quality. There's only one way to find out. I also switched nozzles to a copper nozzle with a hardened steel tip. It's a Triangle Lab ZS nozzle. There was no CHT geometry in this one. Since we've gone this far, let's install the Triangle Lab gears I picked up earlier. I'm curious if they'll give us any differences over stock, but my best guess is they'll just last longer with only minor real differences. This is the K2's extruder. You can see the gears here. Overall, it's a very nice little assembly. Yeah, so I bought this scale like 3 years ago for hot end testing. Hopefully I can use it a bit more next year. I really want to do a video as an excuse where I can buy like 50 hot ends or get my hands on 50 hot ends and then, you know, test a bunch of them and just talk about hot ends for an hour or two. 51.22 grams. As much as I would love to fiddle around and design a custom extruder, it uses quite a few different sensors and boards which would have to be adapted if I wanted it to work exactly the same as before. Should be more than doable though, will be good fun. And this comes out nice and easily. Now we do it in reverse. So the stock gear weighs 8.4 grams and the Triangle Lab one 7.58, so that's a difference of 0.82, 82? What is the unit here? Installing that spring, however, took like 5 to 10 minutes. Bit of a compromise. Complete. Super easy that was. With the gears installed, it was now back to the test prints. It was time for a large ABS glass fiber print batch to really test it all. So there's a bit of an issue. You can see there 55 out of 60. The back fan is on, that one there, and it's exhausting a bunch of the hot air. So I'm not sure why it's doing that when we need it to heat up. It's currently doing the flow calibration. Very interesting. Well, this is something, but I'm glad it did stop the print. It did save it. I mean, it's only a few layers in. But the filament snapped because it's quite brittle. So yeah, good save. So that took just shy of 9 hours. It did turn out better than before, but there's still some artifacting. So I'm gonna do some tests on some really tall prints and see if I can figure that out. Might be to do with Z-Hot, might be to do with something else. Interrupting the sword prints, my sibling wanted a Flexi Shark to give to a friend, so the 0.12mm layer height and I made that happen. It turned out nicely. Back to the ABS, I wanted to do a huge batch of complex parts, and as half expected, a few issues arose, but not until I checked on the overnight print in the following morning. Okay, it's cooled down a little bit, so it should be good to take it out. I've actually heard the prints like cracking off the bed. Now that turned out beautiful. Now would be a good time to tell you that from room temperature, with the bed set to 110 Celsius and the chamber set to 60 Celsius, it takes roughly an hour to get that enclosure up to that value. I have no experience with other 300mm enclosed machines with heaters, so I have no idea if this is a norm or if it's on the longer side. It's fine for the pleasing results I've been having. Back to the ABS testing, I did the classic Benchy and all-in-one test print alongside some flow rate testing, which I was pretty curious about. Unfortunately, the testing I did was rather flawed and I should have had the web interface open and done a different script, or at least run a modified version of the Orca Slicer 1, as one wall was definitely causing the quality to look worse, making judging when the hot end was starting to struggle a bit harder. That was a fault on my end. Since it'd be good to go through all the prints in one big go, let's do that after a special little announcement. This is pretty exciting as it's my first batch of filament from Pixel Filaments. They're the new channel sponsor for filament, which is pretty exciting when I want to start doing bigger projects. So I've got a few spools from them. Let's take a look. And I am so hyped. So this is the PLA Max Cryo Frost. What have we got here? We got the matte PLA. BIOS. It was really interesting hearing about their naming scheme because of copyright. You know, you got to have some unique and good names.
Scarlet. I requested one of each of the types of PLAs. We got matte, PLA, Hyper PLA, PLA Max, ASA. I have never printed ASA. 5 years, 6 years of printing, never printed ASA. Singularity. I haven't printed PETG in 5 years, never printed translucent. Ruby. Basic PLA. Royal. Finally, I know what this is. This is the carbon fiber PETG, isn't it? Beautiful. Singularity. It's really neat. I'm really excited to give these a go, and I know that the first one I want to try... Actually, which one do I try? Nah, it's got to be the PETG-CF, because I remember that the last spool of this I had is a whole lot more expensive than this one by like 50%, and I wasn't getting great results. So I'm hyped to give this a go up first. Let's get some Benchys. Now, I heard that they are using Bamboo Lab refill spools, which is interesting. I've never seen a Bamboo Lab spool, so I have no idea. We got some specs, and yeah, let's get to printing. Print just finished. I can't resist. I have not printed PETG carbon fiber in so long. What a beautiful material. I need to get this dialed in. First ever print with this.
Unfortunately, this was the last print I did on this machine before it threw me another tantrum. Here's the first time the error happened, which had me stumped.
It failed.
The issue immediately had me suspect the strain gauge, but it was fine as I was able to swap the Creality Highs one over, which worked once out of a bunch of attempts, removing that factor. I continuity checked the cable, which seemed fine, frustratingly, but it was hard to truly verify if that was the cause, but it's the only possible one, given the machine was somehow able to home the Z once, but not again. I just have to wait for the replacement parts and keep guessing. Okay, let's now go through what I believe are over 90% of the prints I've done on the K2 Pro. There's a few, so we'll categorize based on PLA, ABS, and then others. First are the many PLA Benchys that I did. I'm aware there are better tests than the humble Benchy, but I still love it, and if a machine can't produce a pleasing copy in this day and age, then it loses a few points in my book. To each their own. The majority of these were printed in Anycubic high-speed PLA purple, which I think is a good all-around filament. The slicer settings vary quite a lot with these, and it's obvious the quality varies too. I did get a few nicer looking ones while experimenting with the seam settings, but as I didn't do a good job of taking notes this time once the numbers were starting to add up, we'll move on. I won't make that mistake again. About 70% of the total prints are using Creality's default slicer settings, which are these values here. Continuing with the Anycubic Purple PLA, I did 3 sets of both Benchys and all-in-one tests, adjusting the flow, retraction, and speeds each time. They all look similar, and they all succeeded with the tolerance test down to 0.2mm. The Benchys this time turned out fine, but I'm guessing I'm just much worse at tuning than I think I am. I did another 4 all-in-one test prints, which performed well in the overhangs and outer walls department, although my top extrusion value didn't save in the slicer, and the stringing is still pretty bad. Aside from the larger prints, like the giant needle, these smaller ones seem to be a lot more demanding with calibration and filament. The green prints are using the Creality Hyper Marble, which was one of the few spools Creality provided for printing with the machine. They also provided some purple, gold, and something else too that I'll put on screen. The Hyper range is quite good. The same goes for the 4 Hestia knives I printed all in Anycubic PLA. These were my first encounter with this artifacting, which I'm assuming are VFAs that are emphasized by the lower layer height. Even after tensioning the belts to 110 Hz and retuning input shaper, the patterns remained. I want to point fingers at the smooth idlers that make contact with the toothed side of the belt. Because of this hunch, I did consider taking apart the machine to swap them out, but not only do I lack that sized pulley, which was a 9mm variant, I was dissuaded to take the machine apart upon hearing that it's not, well, possible. There are 0 tutorials on this level of disassembly, and while I was tempted to just go for it, I'd rather make sure this machine can be repaired or at least returned to how it was stock first. I've already ordered a replacement strain gauge, toolhead cable, and generic hot end. A few more generic PLA prints, such as that shark, a bunch of prism holders for a friend who needed 50 of them, which turned out fine and were a great little test into what print farming could be like. And finally, about 50% of the parts for this camera jib by Mechanistic, which were printed on the K2 Pro in various PLAs. The other 50% were printed on the Creality High. Honestly, both machines felt on par with each other. Although I have had the Creality High for longer, and with it having survived its hot end kerfuffle with no issues since, I'm simply more biased towards it. It's once again conflicting, as I've heard from other Creality High owners how frustrating the machine can be, but to me it's the machine I trust the most in the studio. Just don't mind that I've temporarily gutted it. That's because I needed to borrow the strain gauge sensor to test it on the K2 Pro to make sure that factor was eliminated. Oh, and to have the machine presentable for this shot here and for the thumbnail, which I need to figure out. I believe that's all for PLA, and that's probably for the best as everything seemed to vary quite a lot with how many factors there are. I'm pleased to say my testing with ABS, especially ABS glass fiber, was much better. Let's start with that. The all-in-one test overall came out really well. The bridging is nearly 10 out of 10 with the overhangs looking amazing too. Top surfaces look fine, retraction could be increased, and the tolerances were all cleared. The outer walls look great, with still room for improvement. But overall, it's a very nice print which I'm very pleased with. The Benchy, however, is at least a bit better and one of my favourite prints so far. I printed a similar one on my V0 at the start of the year, and the differences are quite interesting. The colour is actually a little bit different despite it being the same filament, so I'm wondering if temperature or the hotends used are impacting this equation. The V0's finish seems a bit crisper than the K2 Pro's, but it's also a bit rougher in some areas. I think the K2 Pro pulls ahead here, although it does cost twice as much as a V0. In the contest for a small, fast, enclosed and fully open source 3D printer, the V0 dominates that space, no question. Another print was the 3D Boaty, and unfortunately, despite it looking good on some areas, the overall marking loses quite a few points with the bridging struggling a bit. I should have upped the part cooling. I of course printed this big sword out of ABS glass fiber as well, but when entering the studio at night, I stepped on it, completely shearing the top off. I've mostly repaired it now with super glue. It's an overall okay print, but as a photography prop, which was the main goal, it's more than suitable. The handle, and I believe this part is called the guard, turned out super nice with only some minor top extrusion needed. But the blade pieces, which I bulk printed vertically, are lacking. This can be seen across almost all of the blade pieces. I'm wondering if it has something to do with Z-hop, which I experimented with turning on and off throughout my time testing. The final few ABS glass fiber parts we already touched on earlier, so we'll move on to just regular ABS and ASA. This is Orville 3D ABS Plus, which is my only spool of ABS, and I quite like it. My V0 is made up of a decent amount of it. A few of the Boatys failed, but much like the ABS glass fiber ones, the quality is great aside from the bridging needing work, and the edges seeming to be a bit bulged in some areas. The All-in-one Tower has minimal stringing, fantastic bridging, which would be perfect if the 5 strands here weren't drooping, and the outer walls look good, but I did notice some VFA patterns or whatever slightly higher up on the part. The Benchy is a similar story with good outer walls, no stringing, and enough points to get it an 8 out of 10, but it's still not perfect. I'm pleased enough with it though, and the bulk ABS testing I did earlier is something I want to talk more about. It felt very hit or miss, as while it did complete overnight, which was pleasing for a 0.12mm layer height ABS print, some parts barely succeeded, and after the initial test I couldn't get some to print again. Specifically this bowl here. It barely completed the first time and I just couldn't get it to print a second time. It's 100% a skill issue and any tips on that would be really appreciated. Everything else printed fine, although the outer walls aren't looking amazing here. I'm not really sure why that is the case. Maybe the 0.12mm layer height is emphasizing something? I don't know. I'm pleased this planetary gear thing worked out though. Moving on to ASA, I only did 2 prints with that, and despite my lack of experience with the material, the prints turned out fine, and I look forward to trying it again soon. To end on another material I've never really printed, we have Pixel Filament's translucent PETG and carbon fiber PETG. Despite the bridging struggling immensely, the surface finish of these have turned out very nice. Like the ABS-GF, translucent and CF PETG do well at hiding minor imperfections. The Benchys as well turned out extremely nice. I'm very excited to use these materials going forward and overwrite my subpar memories of using PETG in the past. Some additional last minute notes that I want to splice in. The extrude and retract functions weren't seeming to function a couple of times, but this was not tested in the latest firmware for obvious reasons. Also, the glass that they use on this machine, I don't know if it's tempered or whatever, but I've nearly broken it at least 4 times and it's still fine. So that's great and lowers the chances of Uncle Jesseing your door. Overall, and what I was hoping to say in my planned conclusion before the final error was, the machine's fine, it prints fine, the speed is fine, and overall it's fine. But now I can't say that when the machine isn't in fully working condition, regardless of modifications done. That's because the hot end issue shouldn't have happened during a simple nozzle swap, and after printing 100 hours with the Rapido Ace installed, that eliminates the chance of that mod causing any failures. Again, I'm leaning towards the cable being at fault here. We'll just have to see when the replacement parts get here, but I don't know if this is a machine that I will keep, even as a tinkering platform, unless that's highly requested, but I already have some more suitable candidates for that place. I hope there was at least some sort of value for you in this video, and I hope that wasn't too much rambling, although I couldn't help but feel that it could continue for quite a bit longer. There is so much to discuss regarding a machine, especially this one, and I realized that I'm not as cut out for it compared to some of the other amazing speakers out there, like Aurora, Michael, and Daniel, to name a few, who are my go-tos for machine reviews. While this video is technically a review, it's not as comprehensive as it could be, so as always, I recommend cross-referencing material from several videos and articles and try to pinpoint the info that you are after. If there's a question you think I can answer, please let me know and I'll see what I can do about that. I'll try and keep the pinned comment updated with anything I've forgotten, which will be a few things. Pretty sure of that. As that's all for now, it's time to mention that the custom printer series is about to begin, and that calls for some change. Over the last 6 months, my time spent on YouTube and anything that relates to my work hasn't been feeling quite as good as it used to. This is likely due to a change in approach and getting more settled in with everything. I'll see about switching up my schedule to a more balanced work-life one, and to ultimately result in videos that I'm more proud of and videos that you guys really enjoy, which is the most important thing. I'm not sure when the next video will be, but I can promise it will be a nice step forward, as always. We just have to get started. As for now, that's all for this video, so if you made it this far, thank you so much for watching, and hopefully I'll see you again soon. And I think I'm going to include some bloopers in this one. There's quite a few. Kind of just have to go for it. Oh no, this is going to be tricky. It's like 4,500 words, this script. I can't read the teleprompter. And removing a few shipment protection peaches. Peaches? Their customer service flagged the model as having a bit of a risk in transit, so they suggested, wow, their eighth project's design, Under the tool head are some LEDs and a camera for the, what does that say? Moving on the printer. The difference between the completed part and the prototype were right. What? No, night. Oh my, I'm actually losing it.